So for my first video assignment, I'm going to be talking about friction, and then I'll be doing an example from the book that relates to friction. First, I'm going to explain what friction is. So, when an object is in motion on a surface or through air or water, there is resistance to the motion because the object interacts with its surroundings. That resistance is called the force of friction. Friction is important to everyone. It allows us to achieve motion by walking or running, as well as through our many modes of transportation. There are two types of friction: static and kinetic friction. The force that resists lateral movement of two objects that are in contact with each other is called static friction. When two surfaces are moving with respect to each other, the frictional resistance that is created is called kinetic friction. The level of friction that different materials exhibit is measured by the coefficient of friction, and the coefficient of friction equals F over N, where F is the amount of force that resists motion and N is the normal force. So, in the example drawing, we have a man pulling a metal block with a rubber block on it moving along with it up an asphalt incline. As the man pulls the block upward, he has to overcome the force of gravity on the block, as well as the kinetic friction between the asphalt and the metal block. The rubber block stays on top of the metal block right here because the static friction between the metal block and the rubber block is greater than the force of gravity acting on the rubber block. So for the example from the book, we have a 25 kilogram block is initially at rest on a horizontal surface. A horizontal force of 75 newtons is required to set the block in motion, after which a horizontal force of 60 newtons is required to keep the block moving with constant speed. Find the coefficient of static friction and the coefficient of kinetic friction between the block and the surface. What do we have here? So to begin, we start by writing down our the known information. So we have the static force of friction, which is 75 newtons, the kinetic force of friction, which is 60 newtons, and the mass of the block, which is 25 kilograms. To begin, we're going to try to find the normal force, or the force of gravity acting on the block. So first, which in the normal force of gravity is mass times acceleration, which in this case would be gravity, which is 9.8 meters per second squared. So mass is 25 kilograms times 9.8 meters per second squared equals 245 newtons, which is kilograms times meters per second squared. Next, we're going to find the equations to find the coefficients of friction, which the force of static friction equals the coefficient of static friction times the normal force, and it's the same for kinetic friction. So to begin, we're going to find the coefficient of static friction, and so right here we start by plugging in our known values into the equation. So 75 newtons equals the unknown coefficient of static friction times the normal force, which is 245 newtons. From there, we algebraically solve for the unknown coefficient of static friction, which is 75 newtons over 245 newtons. The newtons cross out, and we get the coefficient of static friction, which equals 0.306. Next, we do the same to find over here with the equation to find the coefficient of kinetic force, or kinetic friction, rather. So we plug in our values into the equation. We begin by saying 60 newtons is equal to the unknown coefficient of kinetic friction times the normal force, which is again 245 newtons. We algebraically solve to find the coefficient of kinetic friction, and 60 newtons divided by 245 newtons. The newtons cross out, and we're left with the coefficient, which is 0.2